So continuing with chemical thermodynamics, let us now discuss the measurement of internal energy change and enthalpy change with the help of calorimeter. Delta U and delta H. So delta U is called as internal energy change and delta H is called as enthalpy change. The heat absorbed at constant volume from a chemical change, it is called as internal energy change, or it is also called as the enthalpy of reaction. It can be calculated with the help of calorimeter. This method is also called as calorimetry because apparatus used for this purpose is calorimeter. It consists of simple calorimeter consists of a bath having insulated walls. So simple calorimeter, it consists of a bath having insulated walls. There is another vessel in this bath. This bath where reaction is to be carried out, it is called as the reaction chamber. The reaction chamber is immersed in water so as to record the change in the temperature during the reaction which is taking place in the internal vessel. The water bath is provided with stirrer arrangement to shake the solution and to record the accurate temperature. There is one thermometer in the internal bath. Now first of all, what is done is the heat capacity of the calorimeter, it is to be determined. For this purpose we take W1 gram of water in the calorimeter. It is cold water, its temperature is recorded, let it be T1 degree centigrade. With temperature is T1 degree centigrade. Then this water is mixed with another sample of water whose weight is W2 gram, that is hot water, with temperature T2 degree centigrade, and then this mixture is shaken well. Till temperature of the mixture becomes constant. Let it be T3. So when temperature of the system becomes constant, that is T3, the heat capacity of the calorimeter can be calculated with the formula. It is given by W2 weight of hot water, it is given by T2 minus T3 multiplied by W1 weight of cold water upon, you will be saying T3 minus T1. So this is the formula which helps us to calculate the heat capacity of the calorimeter, and then to know the enthalpy change or internal energy change at constant volume. What is done next? The heat absorbed or produced can be calculated by adding W gram of water in the bath at temperature T. A known mass of the reactant that is now immersed and that is burned in the internal vessel, and the water which is surrounding that internal vessel, its change in temperature is then recorded, and when the change in temperature is recorded, then we calculate the heat change so occurred when the known weight of the substance that is burnt inside the vessel. So for that purpose we will be having, let it be the heat capacity of the calorimeter, the heat change occurred, that will be given by W2 T2 minus T3 into W1. This will come here. Now it is to be multiplied by the specific heat of water, which is surrounding the internal vessel where compound has been burned, and multiplied by delta T, that is change in temperature of the water taken outside the vessel in which the compound is burned. Then we have the measurement of delta H. This heat change is measured at constant volume. So it is called as QV or it is called as delta. Then we measure the delta H, or we can say QP. The enthalpy change measured at constant pressure, that is called as delta H, or that is called as the QP. Now it is done in bomb calorimeter. In this method, a small amount of weighed substance, let it be your m gram, it is burnt in the calorimeter, in the platinum cup of the calorimeter, which is filled with oxygen at 20 to 25 atmosphere. It is now sealed from outside this chamber. Water is filled in, and outside this chamber we are having a water whose initial temperature is recorded, and then substance is burned in the bomb which is inside, where platinum cup is taken, where weighed organic compound is kept, and oxygen gas is filled in that bomb. Now substance is burned, and the change in temperature of the water which is present outside the bomb, it is recorded. It helps us to know the heat change or enthalpy change at constant pressure, that is given by formula Q is equal to, it is QP or delta H is equal to Z multiplied by the delta T multiplied by M, is capital M upon M. Now what is Z here? Z is called as heat capacity of the calorimeter, calculated above. This was the heat capacity of the calorimeter. Then we have delta T, it is the change in temperature of the water which is taken outside the bomb calorimeter, and capital M is the molecular mass of the substance, and small m here is the mass of the substance taken. We took W gram. Instead of using small m, we can also use small w. So this will give us the heat capacity at constant pressure or enthalpy change at constant pressure. So this helps us to know the enthalpy change at constant pressure. Then comment upon the statement. This is another question of us. Comment sun as a ultimate source of energy. So it is true to say that sun act as a ultimate source of energy, because all forms of energy which we are using comes from solar energy, that is the energy from sun, because sun causes the wind tides, it causes ocean waves from which energy is generated. We use them as a source of energy. Ocean currents, geothermal power, it all comes from the sun. Secondly, sun by taking solar energy, the plants synthesize the carbohydrates which act as a food for animals as well as those of humans, and this food act as a source of energy to us. And then the excreta produced from the animals as well as the marine animals, their fossilized forms, they are also used as the source of energy, which also come directly or indirectly from the sun. Sun causes rainwater, which is also a source of hydroelectric power. So ultimately we can say all types of energy, whether it is fuel energy, fossil energy, it is wind energy, ocean waves, or the water waves, that all comes from the sun. And this is very important for us, since this energy also forms the basis of life on our universe. That's why we say that sun is a primary source of energy, because all forms of energy, whether it is the ocean waves, tidal waves, geothermal power, rainwater energy, hydroelectric power, fossil power, fuel power, and your nuclear energy obtained through nuclear fission and nuclear fusion, all types of energy, they directly or indirectly, they come from the sun. So we can call sun as a solar ultimate source of energy, because if there would have been no sun, there would have been no solar energy, and there would have been no life possible without the existence of the sun on this earth.